Hello, JPJ Discovery followers. Ready to dive into some space science? Today, I'm unraveling the orbital mystery behind why Earth gets closest to the Sun in January. You might think it has to do with the seasons, but surprisingly, it doesn't. So, what's really going on? Let's talk about perihelion. Perihelion is the point in Earth's orbit where it's closest to the Sun. It happens every year around January 2nd. The term comes from Greek peri, meaning around, and helios, meaning sun. Now, here's something cool. Earth's orbit isn't a perfect circle. It's actually a bit squashed, or elliptical. Because of this, there's also a point called aphelion, when Earth is farthest from the sun, usually occurring in early July. But why does this happen? It's all about gravity and the shapes of orbits. Most orbits in our solar system are elliptical. That means the distance between a planet and the sun changes as the planet travels along its path. During perihelion, Earth is about 91.4 million miles from the sun, and during aphelion, it's about 94.5 million miles away. You might wonder, does this distance affect our seasons? Not really. The seasonal changes are caused by Earth's axial tilt, not the distance from the sun. So even though we're closer to the sun in January, we still experience winter in the northern hemisphere because the axis is tilted away from the sun. Let's put this in perspective with some other celestial bodies. The orbits of Mercury and Pluto, for instance, are much more eccentric. We have a video about Mercury's orbit. You can check it out at JPJ Discovery. Mercury's orbit varies significantly between perihelion and aphelion, while Pluto's path is quite elongated. On the other hand, planets like Venus and Neptune have almost circular orbits, showing minimal difference between their closest and farthest points from the sun. Speaking of orbits, did you know the sun doesn't sit perfectly in the center of these ellipses? It actually follows a tiny elliptical orbit around the center of gravity or barycenter of the solar system, which isn't exactly the central point of the ellipse. One fascinating example of perihelion in action is NASA's Parker Solar Probe. This spacecraft swoops incredibly close to the sun to gather data, then retreats beyond Venus's orbit to cool down. It's designed to withstand temperatures over 900 degrees Fahrenheit. The perihelion is a fascinating reminder of the dynamic dance between Earth and the sun. Even though it doesn't impact our daily weather, it's a crucial part of our planet's orbital journey. Got more space questions? Drop them in the comments below. Thanks for watching, and don't forget to subscribe for more cosmic adventures.